Okay, chapter 8 talks about periodic functions. So sine, cosine, tangent, and then the reciprocal function. Chapter 8, we're going to look at the graphs of sine and cosine and how those work. So sine is periodic, and the periodic just means that it repeats over and over again. So the same shape is going to happen over and over and over and over. So if we look at this graph over here, the table is at different radian values, what you would get by sine when we plug it in. We figured those out last time. And then if we graphed them, this curve would just keep repeating the same shape over and over and over again. So it's periodic because this pattern, up, down, up, like that, repeats over and over again. The positive values are when sine is positive, so quadrants 1 and 2, and then negative values are when sine's negative in quadrants 3 and 4. And this one is considered odd because it would be symmetric about the origin. Cosine is similar. We have a table of those values. This one just starts at the max and goes down and up. Period is still 2 pi. Repeats that over and over again. Positive values are when cosine's positive. Negative values are when cosine's negative. The domain of both of these is all real numbers because you can plug any value into sine and cosine and get something. The range is negative and 1 to 1. So if you look at the height, that tells you the range. The lowest they go is -1. The highest they go is 1. And then that unit circle that we talked about is how often this repeats. So if you think about it, you go from 0 degrees to 360. And then if you keep going, it still adds up and you have 720 and so on and so forth. But it's still the same value on our unit circle. So it's still going to be the same point on the graph. That's kind of how that works. So sine, here are the two together. So this top one is sine. The bottom one is cosine. They look very similar. With shifts, you can put them right on top of each other. Sine always starts at the origin, where cosine starts at the maximum. The period is when it returns back to that point. So for sine, you go back to the origin. Cosine, you go back to the maximum. Sinusoidal function, all that means is a function with the shape. You can, because they're just shifted, you can write either one as a sine or cosine. So if you see that word, it's just saying one that looks like this. So all that first page really is just information. Next page. This is the general form. So if it's just sine x, that's the parent function. This is either A, B, C, or D. If those are numbers, they're going to change how the curve looks on the graph. So the parent function is y equals sine x. So all of that information we just talked about is for the parent function. And then cosine, same thing. If we go into the ones with the others, the period of the parent function is 2 pi. So depending on what happens with b in our equation, it's going to change the period of the graph. And then that's the horizontal stretch or squish. So if we think back to transformations, whatever's multiplied by x is actually going to change our period. So because the original period is 2 pi, we're just going to divide by whatever b is to get the new period. So in this graph, b is pi over 6. That's the number in front of the x. So to find the period, I'm going to do 2 pi, which is the original period, divided by pi over 6. So when you divide fractions, you keep the first one, change it to a multiplication problem, and then flip the second fraction. 2 pi times 6 is 12 pi. 1 times pi is pi. And then those are going to cancel, so my new period is 12. That just means on a graph, that sine shape is going to repeat all the way to 12. So instead of being 2 pi, this is going to be 12. Because cosine's the same, we do the same thing. So here, b, now if we look, this says x over 3. X over 3 is the same as saying 1/3 times x. So b is 1/3 in this one. So to find our period, we're going to do 2 pi divided by 1/3. Keep the 2 pi, change to multiplication, flip. So 2 pi times 3 is 6 pi. 1 times 1 is 1. So the period of this graph is 6 pi. So that's how you figure out how often you repeat. The amplitude is another word from the height. So on these graphs, they have what's called a midline. So the line that goes through the middle of the graph is on the parent function 0, but that's the midline, same distance below as above. Amplitude is this value here, amplitude. So it's the height between the midline and the top. Height between midline and the top. So the amplitude of the parent function is 1. That's the vertical stretch. So that's how we're stretching out the value. And we always look at the absolute value because we're talking about a height. So we take a, which is the number in front. So amplitude is going to be the absolute value of -4, which means 4. So the height of this curve is going to be 4 from the middle up. So you're going to go 4 up and 4 down. So if we did this one, amplitude is 1/2, and then, so it would stay 1/2 because it's already positive. So those are two of the key features, the period and the amplitude. Another key feature is the phase shift. The phase shift. So that's the horizontal displacement. How much does it shift left or right before it repeats? So C, that number inside the parentheses here, that's going to be your shift. And the number is the magnitude, so it's the absolute value. And then plus or minus is whether it shifts right or left. So what we do here to determine the shift is we take whatever number is added or subtracted. So in this case, it's pi over 6. So our magnitude is pi over 6. And because it's positive, our direction is left. So if we look at the U-try, our magnitude is pi over 2. And the negative tells us we're moving right. So if the period is still normal, if there's no change to the period, it's that simple. If there is a change to the period, I'll show you in just a little bit the one extra step on that. And then the vertical shift just shifts the midline. It's saying, hey, the center of the graph is moving up or down. That's D. Positive is up, negative's down. So if we look at example 4 here, at the end we have -3. So that means we're going to go down 3. If we look at the U-try, at the end we have +2. So we're going to go up 2. So those are all the pieces. The vertical shift, the horizontal shift, also known as the phase shift, and then our period and our amplitude. So let's put it together. So midline, vertical shift, amplitude, period, and phase shift for the function. So our vertical shift is up 1, which means the midline is going to be a horizontal line at y equals 1. That's how that part works. So midline. Okay. Now we have our amplitude. So amplitude is going to be the absolute value of 3, which is 3. Then we have the period. So that we take the number in front of the x, period, and we do 2 pi divided by 2, so we get pi. And then the phase shift, there is nothing added or subtracted inside the parentheses, so the phase shift is 0 or none. All right, let's look at this one. Now notice in here, we have a period change and a phase shift. So before we can do anything, we need to take that period out. So x over the 3 is the same as saying 1/3. So x over 3 divided by 1/3 is x. And pi over 3 divided by 1/3 is pi. So what I did here was I factored out the period change. You have to do that whenever it happens to both. So whenever phase shift and period shift happen, at the same time. That's when you have to factor that out. So if I rewrote this, it would just look like that. Now we can do everything. So our midline and vertical shift is going to be this. So we're going down 2. That's our vertical shift. So our midline is y equals -2. The amplitude is the absolute value of 1/2. So it's 1/2. The period is 2 pi divided by the 1/3 I pulled out. So to divide fractions, we keep the first, change to multiplication, flip, so we get 2 pi. And then our phase shift is going to use that new one after we've divided by the period. So our phase shift is going to be right pi. That's how that part works. When you have the equation of the graph, you can write, or when you have the graph, you can write the equation. Sometimes they're going to tell you if it's cosine or sine. Other times you decide. They say just find the sinusoidal function. So I'm going to show you how to do both. Once you decide if you're sine or cosine, you're going to just write whatever we're looking at. Then we find all the pieces. So the amplitude, the period, the phase shift, the vertical shift. We find those right on the graph and then add those in. So the vertical shift is the easiest thing to start. We find the middle. So that's our midline, and it's at 0.5. So at the end, we're going to have a vertical shift of plus 0.5. That's the easiest thing to find first. Then we can find the amplitude. From that midline, we go up to 1. So our amplitude is 0.5. Now, our cosine usually goes max to max. So we have a high point to a high point. If that's the case, our A is positive. If it goes a minimum to our minimum, our A is negative. So for this curve, if we start at 0, we end up going minimum to minimum, so we would make this negative. Then we do our period. So if we look, we start at 0, we end at 2 pi, so that's just our normal period. The period's 2 pi. And then our phase shift is how it shifted from the origin. This one still starts at the origin, so we don't have a phase shift. So that's our equation. All right. So we decided again, our vertical shift, was based on our midline, which was right here at 0.5. That's why I'm going to add 0.5 at the end. Our amplitude is the height from the midline to the max, so that goes up 0.5. And because our curve goes from a minimum to a minimum, that makes our 0.5 negative. The period starts at 0, ends at 2 pi. So that's our normal period. So we don't do anything in front of the x. And our graph starts at 0, so we have no phase shift. That's our equation. Let's follow those same steps for this graph. Period, phase shift. So first we're going to find our midline. The middle of that is 2. We know it's sine. So we're going to add 2 at the end. Our amplitude, we go up from the midline to the top. So that went up 1. Now sine usually goes up first. So from the beginning, if we go up first, our A is positive. If we go down first, our A is negative. So this graph goes up before it goes down. So we're going to leave that as a positive 1. The period, we start at 0 and go to 2 pi. So that's our regular period. We don't need to do anything to the x. And the phase shift, we start right on the y-axis, so we don't add anything. So that is the equation. Okay. Now, if I tell you to determine it, you can do either. You can do sine or cosine. So I'm going to show you both. So let's start with sine. So if I say this is sine, first I want to find the middle. So we go 1, 2, 3, 4, 5. 6 is the total. So our middle has to be up 3. So that right there is going to be our midline. So at the end, we're going to put -2. Now I'm going to trace the sine curve. So I'm going to decide to start here. I'm going to go up first and until I come back to the up. So that's 1 period. So let me figure out the amplitude. So that's up 3. And we went up first. So sine is positive. Then we look at our period. So we start at about -0.5. And we go until about 5.5. So if I subtract 5.5 minus -0.5, I get 6. Just like to find the period, we did 2 pi divided by the number. We're going to do the same thing. I'm going to say 2 pi divided by 6. Reduce that, I get pi over 3. That tells me that I'm going to multiply my x by pi over 3. So the x is going to go in here with that pi over 3 in front. Now we do our phase shift. So this dot is left about 0.5 from the y-axis. So I'm going to put plus 0.5. So we're just doing all of that in reverse. Now you can leave it like this, or you can distribute the pi over 3. It does not matter. That is up to you. Now I'm going to do the same thing, but I'm going to do it if we were doing cosine. So this time I'm going to do cosine. So I'm going to find the midline. That part's exactly the same. I'm going to find the amplitude. That part's exactly the same. And I'm going to trace my cosine curve. So I start from a max to a max, so I can leave that as positive. Period's going to be the same process. We start at 1, we end at 7, so my period is 6. So I would do 2 pi divided by 6, which means I'm going to multiply my x by pi over 3. And then my phase shift, I start at 1, and it's to the right. So because I went right 1, I'm going to put minus 1 in here. Now, if I typed either one of these equations in a calculator, I would get the exact same graph. So it does not matter which you do. I recommend you pause the video and try this one on your own. And then when you're ready, come back and see how you did. All right, I'm going to do the same thing. I'm going to do sine and then cosine. Where we go? Here, okay. Do sine and then cosine. So, sine. First, I find the middle. So, my vertical shift, or my midline, is up 4. So, I'm going to add 4 to the end. That does not matter which one I do. The amplitude is from that midline up. So, the amplitude is 4. That doesn't matter which one. Now, we're going to look at the differences. And it all depends on where you highlight. So if I do the sine, I'm going to highlight this part. That's going to be my sine curve. So now we went up first, so my amplitude can stay positive. Now we need to do the period. So we go from 1 to 11. So the period is 10. So to figure out the number we put in here in front of x, we're going to do 2 pi divided by 10, which simplifies to pi over 5. So that part doesn't change no matter whether it's sine or cosine. Okay, so this and this don't change. Amplitude, the sign changes. And now it's the shift. That's really what the difference is. So this point is at positive 1. So we went right 1. So in here I write minus 1. For cosine, the curve would be max to max. So this point is at 7. So it's left 7. So I'm going to write plus 7. That's the only difference in there. There's other versions you could do. If you had chosen to highlight the cosine from minimum to minimum, this would be negative and this would be different. There's lots of different ways. As long as you get the pieces that work, you're good. All right, so now to sketch the graph, you find all those pieces and then put them on the graph. So first, we're going to find the amplitude. Then we're going to find the period. Then we'll find the phase shift. Then we'll find the vertical shift. Then we'll plot it. Okay? So let's start with this. The amplitude is the absolute value of A. So our amplitude is 2. And the negative tells us we're going to go down first. Okay? Now we find the period. So this means we're doing pi over, B is pi over 2. So to find the period, we do 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which is 4 pi over pi, which equals 4. So my period is 4. Vertical shift, there's nothing over here, so there's no vertical shift. And phase shift, there's nothing added or subtracted, so there's no phase shift. So now we plot. Sine starts at the origin if there's no shift. Then we said our period is 4. So we're going to repeat at 4. So there's our phase and vertical shift. If those are the ends, this is the middle. And sine is the one that looks like an S. So it has to touch that midline 3 times. And then we go down first. So we have to go down 2. So in between the 0 and the 2, we go down 2 and make a minimum. In between the 2 and the 4, we're going to go up and make the maximum and then connect. So those would be our dots. And it would just repeat. So it would go down here again and back up. It would keep going like that forever. And then this would just be one period. Cosine is the same thing, but it looks more like a C. And obviously you have to turn them sideways. Start the same way. Why does it do that? Start by finding the amplitude. So absolute value of negative 0.8 is 0.8. And the negative tells us we're going to go minimum to minimum. Because those are decimals, I'm just going to take this and I'm going to make it by 0.2. So like we're going to say this is 0.2, 0.4, 0.6, 0.8, 0.10, and then same things on the negatives. Period. We're going to do 2 pi divided by 2, which is pi. And then vertical shift, there's none. Phase shift, there's none. So our period is going to be from 0 to pi. So that means, like, we're going to start at 0, go to pi, and repeat. So every 4 boxes we would repeat. Cosine's min to min. Our midline's here. So the minimum is down 0.8 from that line. So 2, 4, 6, 8. We go minimum to minimum. In the middle, that means we go to the maximum. And then in between each of those, we cross. So there's that one. And then it would just keep repeating. So max. And it would be that all over again. All right, let's check out another one that's got more of the pieces. So before we do anything here, we have both a phase shift and a period change. So we're going to take that out. We're going to divide by pi over 4. So pi over 4 divided by pi over 4 is 1. Pi over 4 divided by pi over 4 is 1. So that's our new equation. And because that phase shift is 1, I'm going to change our numbers. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to make my life a little bit easier on the grid rather than trying to figure things out. Now let's find all the things. Amplitude is the absolute value of 3, and it's positive, so we go up first. Our period is going to be 2 pi divided by pi over 4, which is 2 pi times 4 over pi, 8 pi over pi, which is 8. So our period is 8. Then our phase shift is that -1. So we're going to go right 1. And there's no vertical shift. So our midline is still that axis. Sine starts at the origin, but we're going to go right 1. And then our phase is 8. So I go 8 more, which ends up being at 9. Then I plot the middle. So that's how we get those original 3 points. Now we go up first to the 3. So in between the 1 and the 5 is 3. So I go up to my maximum. And then in between the 5 and the 9, I go down to the minimum. And that's the graph. So let's do another one. This one, we need to factor that out. So if we rewrite it, we're going to divide by pi over 3. So we get x minus, and then pi over 6 divided by pi over 3 is pi over 6 times 3 over pi. So we get 3 pi over 6 pi, which is 1/2. So our phase, well, that's 1/2 right there. So again, because we're dealing with like an actual number, I'm just going to change these to 1, 2, same thing I did before. All right, amplitude, absolute value of -2 is 2, and its cosine, so we're going to go min to min. Period is 2 pi divided by pi over 3. So I get 6 pi over pi, which is 6. My phase shift is right 1/2. And there's no vertical shift. So our midline's still there. Cosine, we're going min to min. And our amplitude is 2. So our minimum is going to be at -2. But we have to shift right 1/2. So I'm actually going to start my minimum there. And then my minimum again is going to be 6 later. So 1, 2, 3, 4, 5, 6 later. The middle of that is going to be the maximum. So we would go to +2. And then the middle of each of those is where we're going to cross. So in between there and there we cross. And now we have one phase of our cosine. So that is that. You can also put this in the calculator, if that helps you figure out how to draw it. If you hit y equals, and then type -2 cosine, and then in parentheses, you need pi divided by 3 times x minus pi divided by 6. Make sure your mode is in radians, otherwise it won't graph it well. And zoom 7 is trig. That's one way. Or you can just change it to match this. So like this graph went from 0 to 8. So if I change my window to 0 and 8, now I can see, and that pretty much is the same curve. So that can help you as well if you want to do that. But that is section 8.1. Let me know if you have any questions.